Hello everyone, my name is K. Rajesh. I am from CSE B section. Today's my topic is about refactoring for data locality. Introduction. Refactoring a program means transforming its internal structure to improve its qualities such as program organization, execution speed, or readability without changing its functionalities. Although refactoring is most often seen as a way to improve programs' internal architecture, here we use the term to mean improving the execution speed. The main bottleneck often is not a computation time, but rather memory access delay. Processors can execute hundreds of instructions in the time needed to fetch a single word from the main memory. A cache hierarchy narrows the performance gap between processor and memory. Only when the requested data is present in the cache does the system quickly deliver the data to the processor, saving it from data starvation. Basically, caches operate by retaining the most recently used data. If the processor reuses the data quickly, cache hits occur. Conversely, if it reuses the data after the long time, intervening data can evict the data from the cache, resulting in the cache miss. The majority of the processor chip uh, area is typically reserved for caches. Digital microfluidic biochips, a specific class of programmable logs that manipulate discrete droplets of fluid via electrostatic actuation. Figure 1a illustrates the electrowetting principle, applying the microstatic potential to the droplets, modifies the shape of droplets and its contact angle with the surface. As shown in figure 1b, droplet transport can be induced by activating and deactivating a sequence of electrodes. Adjacent to the droplets, the ground electrodes on top of the array improves the fluidity of droplets motion and reduces the voltage required to induce droplets transport. Figure 2a depicts the programmable 2D electrowetting array called the digital microfluidic biochip DMFB. A DMFB can support 5 basic operations shown in the figure 2b. Transport move a droplet from position x, y to x dash, y dash. Split create 2 droplets out of 1. Merge or mix combine 2 droplets into 1 and optionally rotate them in a rectangular motion and store. Place the droplets at a position x, y for later view. A DMFB is reconfigurable as these operations can be performed anywhere on the array, and any given electrode can be used to perform different operations at different times. DMFB compilation. Compilation targeting DMFBs without control flow is mature. The input is effectively a fluidic variation of a traditional data dependence graph where vertices represents fluidic operations and edges represent fluidic dependencies. That is, an edge ui, uj indicates that operation ui provides a droplets di. J that is used consumed by operation uj, as shown in figure 3a. Compilation for a fluidic data. Cloud-based automations allow scientists to remotely execute biological procedures in robot-run laboratories over the internet. Experiments are described using laboratory-specific domain-specific languages. These languages could be extended to encompass LOCs as laboratory components, but would still need to interact with the high-level language to program the device. Yes. Dependence graph must solve 3 interdependent NP-complete problems: operation scheduling, reconfigurable module placement, and droplet routing. The scheduler must determine the time steps at each at which each biochemical operation occurs, while satisfying droplet dependency constraints and physical resource constraints of the device. The placer determines the location on the 2D electrode array, where each operation is performed as the reaction progress over time. The router ensures that droplets are transported from or to their start or stop positions at appropriate times, while ensuring that droplets do not inadvertently collide with one another or interrupt any other ongoing operations on the chip during transport. If needed, the droplet router may introduce wash droplets to remove residue left by functional droplets and travel over the surface of the chip. Compiling a control flow graph CFG onto a DMFB is a active area of research. However, the two techniques proposed to date still compile basic blocks individually and therefore lack a global scope. The first is to dynamically interpret the CFG by just-in-time, compiling each basic block on the fly. As the program executes, as each basic block executes, the runtime performs computation on sensory data acquired from the device, which resolves condition and determine the next basic block to JIT compile. The alternative is to compile the CFG statically. To date, the only technique which has been proposed compiles each basic block is isolation. Using any of the scheduling, placement and routing algorithm listed above, however, the approach to placement taken by the compiler introduces a number of other view unnecessary droplet transport operations, which the placer introduced in this paper effectively eliminates. High-level languages for programmable chemistry. Languages for programmable chemistry includes but not limited to microfluids. Typically fall into one of the three categories: ontologics, laboratory automation, and device-specific languages. For the more general review, ontologics. Ontologics is specific biology, such as synthetic biology, open language, or exact aim to standardize how biochemical scientists discuss and disseminate information in a standardized form. They describe experiments and models in the common language but cannot directly execute the cloud-based automations allow scientists to remotely execute biological procedures in robot-run laboratories over the internet. Experiments are described using laboratory-specific domain-specific languages. These languages could be extended to encompass LOCs as laboratory components, but would still need to interact with the high-level language to program the device. Yes. Device-specific languages for LOCs. BioStream targeted a programmable LOC designed primarily for serial dilution protocols, which coupled a fluidic mixture to a fluidic memory. BioStream abstracted away the device level details from the programmer and includes algorithmic to automatically generate serial dilution protocols for the set of user-specific target concentrations. However, after the initial publication, the specification and compiler were never released. AquaCore is the programmable LOC comprising a collection of micro-value and based components connected to the centralized bus, which is programmed using the assembly like AquaCore instruction set (AIS). BioScript syntax and semantics. BioScript is a language for programmable microfluids whose syntax aims to be uh, palatable to life sciences partitionaries. most of whom are not experienced programmers. We desired a syntax and schematics that experiences operations in a manner that closely resembles plain English. To keep the language small, we do not include operations in the language syntax that can automatically be inferred by a compiler or execution engine. For example, the compiler can automatically infer implicit fluid transfers for a mix operation. Bioscripts further semantics and targets logs technologies ranging from simplest to most complicated. Type systems and safety. The Environmental Protection Agency (EPA) and the National Oceanic and Atmospheric Administration (NOAA) has categorized 9,800 chemicals into 68 reactivity groups, defined by common physical properties of discrete chemicals. It is known as mixing materials from certain reactivity groups can produce materials from other reactivity groups. For example, mixing acids and bases induces a strong reaction and produces salt and water. Conclusion: refactoring for data localities opens a new avenue for performance-oriented program rewriting. SLO has broken down a large part of the complexity and software developers face when speeding programs with numerous catchy misses. Therefore, we consider SLO to belong to a new generation of performance program analysis, whereas existing catchy profiles highlights problems such as catchy misses. Second generation analysis highlights the place to fix problems. Improving data locality is also important in hardware-based applications. SLO was already used to optimize the frame rate and energy consumption in the wavelet decoder implemented on the FPGA. Thank you.